Hello students, it's Mr. Nguyen here. This week you have an assignment that will require you to graph some systems of inequalities. Um, and I would like to take a few minutes to walk you through how to do that. So what you're going to get this week for your assignment is this Google slide. And inside this Google slide, you will have directions on how to complete the assignments, okay? I'm gonna link the video that I'm making to this right here so that you can have a reference to go back and watch it later if you want to. First, you're gonna use a Desmos calculator to graph the system. So you have a total of three systems, okay? So problem one of three, two of three, and three of three, okay? And all the stuff that you have to do over here. And an example slide. This example slide is for me to do, okay? So that you know how to do yours, okay? So I'm gonna make one myself, okay? So you go and you graph your calculator. You're going to label, I'm going to show you how to label all of your vertices of this solution region. Okay, the solution region is where the overlap is, right? When you graph these inequalities. So let me bold that for you guys. Now, and then I'll show you how to graph your constraints. Your constraints for this particular assignment that I give you is y greater than or equal to 0 and x greater than or equal to 0. So these constraints limit your graph to just the first quadrant only, right? So we don't care about all the negative values. Now we're going to go and we're going to find and label all the vertices of the feasible region. Now, there's a difference between a solution region and a feasible region. The solution region could include all the negative values, but once you graph your constraints, you end up with just the feasible region, which is the region of the solution that only include positive values, right? Then I'm going to show you how to snip a picture of this graph and paste that into the space that is inside the assignment, this box right here, right? So you're going to paste that in there so that I could see what your graph looks like. Then you're going to insert an arrow pointing to the feasible region of your graph for me. And then you're going to indicate which of the order pairs that you label could be the optimal solution. To be the optimal solution in a business world, we want to input as much, as little as possible and get as much output as possible. So in our for our purpose, we're gonna look at order pairs that has the smallest x values but the biggest y value, right? So x value would be the input and then y value will be the output. So if you put in little but you get out a lot, that would be optimal, right? So that's what it means for our just in our situation, that's what it's going to mean to be an optimal solution. So I'll show you what that looks like in just a second. So let's get to it, okay? So here's my system. So the system is given to you. You need to do all these three things right here. You need to graph, you need to indicate your order pairs, indicate where the feasible region is, and then put the order pair of the optimal solution in there, right? So my system is y greater than or equal to 0, y less than 2x plus 2, and then 2x plus y less than or equal to 6. The nice thing about Desmos is that you can graph your equations in all forms, right? It doesn't have to be in slope-intercept form. So I could actually enter these equations as they look. So go back over here, click on the link that's provided. It's going to take you to the Desmos graphing calculator, and you're just going to type in your system. So y is greater than or equal to -4. That's my first inequality. It's going to graph it right away. Hit enter, and then you're going to enter the second one. Y is less than or equal to 2x plus 2. That's my second inequality. Then I'm going to go to the third one. Watch this. I can just put this in standard form and it'll still graph for me, right? So 2x plus y less than or equal to 6. Okay. So if you guys recall, we did this kind of like early in the year. I introduced this linear programming to you guys, I think earlier in the year. Now I'm just going to show you guys how to use technology to do some of the graphing. Okay. So here is our three inequalities graph. As you can see, the part or the region where it's overlapping three times would be your solution region. So your solution region is this triangle right here, right? This triangle right here. Notice this triangle, it's in all four quadrants, right? Quadrant one, quadrant two, quadrant three, and quadrant four. That means your solution region actually have some negative value. So now here's the nice thing. If you actually point to the point where that is, it's gonna tell you where that point is. And you could actually take the order pair 1, comma 4 and you plot it, right? So you take that, you can actually plot that, or you can go over here and you type in 1, comma 4 and then label it. It's gonna label 1, comma 4 for you. You can actually go over here to setting and sort of play around with the labeling a little bit. Okay. Then you can enter another order pair right here, which is the other vertex of your triangle, right? So it's down here somewhere. I think it is -3, -4. I'm not sure. If you click on it, it will tell you. Actually, right here, -3, -4. So I'm actually going to type that in, -3, comma, -4. Make sure you use parentheses so that it knows it's an order pair. Hit label, and there it is. It labeled it for you, right? And then over here, click again. It's going to be that order pair 5, comma, -4. So I'm going to go over here and label it. So make sure you label all your vertices, right? What was it? 5, comma, -4. 5, comma, -4. And then check label. Okay, and it's labeled them for you. If you want them to be, I think I want the label to be big. So I'm gonna go over here and change the setting on this one, or medium, right? Make sure it's a little bit bigger. Okay, so now now see, if you go back to the direction, it says find and label all the vertices of the solution region. That's what I just did. I just labeled the three vertices of my triangle, right? Now it says graph your constraints. Your constraint is y greater than 0 and x greater than or equal to 0. So I go over here and I graph those two things. Y greater than or equal to 0. Okay? There's that blue part right there. I hit enter and then now I graph x greater than or equal to 0. Okay, oh, 0. There you go. And then there's that green area. So it's kind of, the colors are like overwhelmingly just difficult to see, right? If you don't want any other color except for the part that is really important, you can actually change them all, right? And here's another nice thing. You can actually move your graph around in Desmos, right? You can click on it and move the graph around. Anyway, so I think I'm gonna go over here and change these to maybe grayish color. Okay, I just turned it off. I think you go to edit and you go over here and you change these to gray, or well, there's no gray, so maybe all orange. I don't know. I'm gonna change it to all orange. Uh, change it to. I just want to be able to see the overlapping parts. Um, so over here, I change this to maybe purple. Change this to purple. Okay. The overlapping part is right here. Can't really see that good with all this color. I don't know how to get rid of all the colors. So I guess you can keep the default color if you want to. Um, um, maybe black. I don't know. If I do black, what would it do? Do black. Oh, I think black is showing better. Yeah, I think black is showing better. Let me see. Let me wonder if I can change that to black as well. Okay. Yeah, if you change it to all black, your feasible region actually shows up better. This is the feasible region right here, right? So notice the feasible region actually have some order pair right here. This one right here, and that is, I think, 0, 2. So you want to actually graph that, right? So comma, parentheses, 0, comma 2. Okay, and then you can label that. Okay, and then notice the origin is also an order pair, right? The origin, so I type in 00, and then label that. Okay, and then notice there's another order pair over here. I think that is 30. Okay, so if you click on there, it's 30 right here, right? So I actually want to graph that as well. So 30, 3 comma 0, and then label it. Okay, so now that after I've done that, if you read this over here, the direction for step 4 has been done, right? Find and label all the vertices of the feasible region, right? So I go back to my graph. As you can see, the feasible regions right here. So I label them all, right? Here's 0, 0, 0, 2, 1, 4, and 30. So now, next step, I'm going to snip a picture of this, right, and put it in my um, assignment, my Google slide. So I go over here, and you can zoom in, zoom out, however you want, but I recommend that you get a picture big enough where your solution region is shown and the feasible region is shown. So like about like that, right? Oop, I just moved it. Sorry. Let me move it back. There you go. About like that, right? And then you go to here, snipping tool, right? If you go to a snipping tool, if you don't have it on your bar or your taskbar already, you can go to app and just hit search for snipping tool, and then you click on that. You hit new, and it's gonna allow you to drag a rectangular area on your screen that will capture this graph. So there it is right there. And then I will hit Control C to copy this image. And I will go back to my assignment. Okay, I go back to my assignment over here, my Google slide, and I would insert this picture inside that box. Okay, Control V. Control V will paste what you just copied, and I'm gonna resize this image. Right? I know my order pairs are all shrunk down and stuff like that, but that's okay. As long as I see your graph and the order pair label, I am good. Okay, so now just sort of try to fit it in there. You can take this box out if you want. I just put a box there, just a placeholder for you to see that you can insert your graph there, right? So I leave my graph there. I think I am going to delete this box so that I have a graph just like that, right? Now the graph is done. Okay, so the feasible regions here. Now it says next, insert the direction sets, insert an arrow to point to the feasible region on your graph, right? So how do you do that? Well, over here, you're going to go to insert and you go down to line and then arrow, okay? And then you're going to start over here, down here, and point to that region. Now, my arrow, I think is purple or black or something, some other color. I want it to pop out a little bit, so I'm going to go to line color and I'm going to change it to yellow, and I'm actually going to make it a little bit thicker so that I can see, maybe 3 times thicker. There you go. So now it's showing better, right? It's pointing to the feasible region for me. So that's what that step is asking you to do, okay? Insert an arrow that points to the feasible region. Now, let's talk about the optimal solution because we have to enter this order pair. If you notice, let me go back to this graph so you can see better. If you notice, the feasible regions here, and there are 4 order pairs. If you look at the origin, that's 0, 0. That's no input, no output, or input of 0, output of 0. Of course, that's not what we want, okay? Now, here's another one. Here's another one. The optimal point is input 0 and output is 2. Okay, if you don't put anything and you output something, that's really what you started with, right? That's like if you're doing a business, that's like your money that you put out. Okay, is that really profit? Not really, right? Now, if you look at order pair 30, 30 indicates you input 3 of whatever and you got nothing out. That's definitely not an optimal uh, point, right? An optimal solution. Let's look at 1, 4. 1, 4. Notice 4 is the tip or the maximum of your Y value, right? And the our input is a 1. So it's what the order pair 1 4 tells you is this is the best place to be if you're doing business, right? Yeah, let's say you're selling something for $1 and you can sell a lot of them, versus selling something for $2 and only sell two of them, right? So for example, this order pair right here. So 1 comma 4 is considered in our context the optimal solution for this systems, right? So you're going to go back to your system and you're going to enter 1, not right there, you enter right here, 1 and then 4. Okay, you don't have to put a comma because the space doesn't allow you to do a comma. So anyway, if you need additional help, you're more than welcome to join my tutorial tomorrow, or well, you don't know where tomorrow is, but it's on Tuesday and Thursday. You can check out the time in your assignment sheet. And I can guide you through the rest of this assignment if you need help. Okay, but anyway, you have 3 problems to do. That's not, hoping that's not a lot. After this video, if you have any questions, you can also email me. Okay, thank you guys for watching, and I will see you in the next video.